In this video, we'll cover acid-base titration and be able to figure out what the concentration of an acid is given the known concentration of a base, vice versa. Let's say we had a solution of hydrochloric acid. We know that there's 20 milliliters of it, but we don't know its concentration, or the molarity. Titration is a lab technique we use to figure out the unknown concentration of an acid. This entails reacting the unknown acid with a known concentration of base. During a titration, we need the pH indicator, which shows a color change depending on how acidic or basic the environment is. You can see this is the first step. You add the pH indicator, and right now it's showing that the acid turns this specific pH indicator blue. During step 2, we prepare a burette, which is a long glassware used for acid-base titrations. It accurately measures how much liquid solution we're going to be adding to our unknown acid. In step 2, the solution that's in the burette is a known concentration of base. It is 2 molar sodium hydroxide, NaOH. There's 15 milliliters of it in the burette. Usually, you fill the burette with more solution than you'll actually need. For step 3, this is the longest step. We turn the burette valve so that it begins to release the base into the acid. This process is the actual titration part, where the hydroxide ions from the base react with the hydrogen ions from the acid to form neutral water. This step takes a really long time because we actually don't know how much of the base to add. We just slowly add it until we are signaled by a color change. Now we're at the last step. The exact moment there's a color change, we have to immediately stop adding base. The point at which there's a color change is known as the equivalence point, or a neutralization point. At this exact moment, if done correctly, the concentration of the hydrogen ions is equal to the concentration of the hydroxide ions in the flask. I want you to notice that there's only 13 milliliters of the base that was used in this titration of the 20 milliliters of the acid. The amount of or volume of the acid and base are really important for our titration calculation. So again, we have 20 milliliters of an unknown concentration of HCl, and that was titrated or neutralized with 13 milliliters of 2 molar NaOH. By knowing how much base was used, we can figure out the concentration of the acid that was in the original flask. So first, we should figure out how many moles of hydroxide ions was used. Second, we figure out how many moles of hydrogen ions was in the unknown acid. And then third, we can divide the moles of hydrogen ions by the liters of the acid to get the unknown concentration of the acid. To figure out the first thing, the moles of hydroxide ions, you can multiply the liters of base by the molarity of the base, which gives us 0.026 moles of NaOH. If there's 0.026 moles of NaOH, then that means there's 0.026 moles of hydroxide ions. Now step 2 is to figure out how many moles of hydrogen ions there is in the acid. This is easy because we know that at the end of titration, the amount of hydrogen ions equals the amount of hydroxide ions. Alright, since we know that 0.026 moles of hydroxide was needed to neutralize the acid, then that means there's exactly 0.026 moles of hydrogen ions. Now the third step is to get the concentration by dividing the moles of hydrogen ions by the liters of the acid. Because the molarity equals moles divided by liters, the liters being 0.02, because 20 milliliters is the same thing as 0.02 liters, you can calculate the molarity. If you do this in a calculator, 1.3 molar HCl. To quickly recap this, we wanted to figure out the unknown concentration of an acid, and after a titration experiment, you'll know exactly how much base was required to neutralize an acid. use those numbers to figure out the concentration of an acid. It turns out that titration problems on paper is actually even easier with the help of a simple equation. The acid-base titration equation is another plug and chug type of equation. As long as you know how to identify what the acid is and what the base is in a word problem, we should be able to just plug it right in and type it in the calculator. So before we do two examples, let's just look at this equation first. The Na represents the number of hydrogen ions for the acid. It's just a number, it has no units. The Ma is the molarity of the acid. The Va is the volume of the acid. The Nb is the number of hydroxide ions for the base. Again, this one is just a number, it has no units. Mb is the molarity of the base, and Vb is the volume of the base. For Na, here's some examples. HCl, or hydrochloric acid, only has one hydrogen ion, so Na is going to be 1. While sulfuric acid, or H2SO4, has two hydrogen ions, so for sulfuric acid, Na is 2. Pretty simple. Nb is the same idea for bases. Sodium hydroxide, or NaOH, has one hydroxide ion, so Nb for sodium hydroxide is 1. While for beryllium hydroxide, or BeOH2, it has two hydroxide ions, so for Nb, for beryllium hydroxide, it is 2. Now here's the first example. In a titration of sodium hydroxide with sulfuric acid, 20 milliliters of 5 molar sulfuric acid was required to neutralize 100 milliliters of the base. What is the molarity of the sodium hydroxide solution? Now this problem already says it's a titration problem, but you should also know that it's a titration problem because it involves solving for a concentration of a base, and we know the concentration of the acid. So we write down the titration equation. According to this problem, we want to solve for the molarity of our NaOH, the concentration of the base. And the concentration of the base is represented with Mb. We should know or be able to identify everything else from the problem. So let's go ahead and get started. In the titration of NaOH with H2SO4, 20 milliliters of 5 molar H2SO4. So H2SO4 is an acid. We have 20 milliliters of it, so we know the volume of the acid is 20 mils. 5 molar of acid, so we know the molarity of the acid. H2SO4, how many hydrogen ions does that have? Well, H2, so it has 2 hydrogen ions. Na equals 2. So we know that that was required to neutralize 100 milliliters of the base. So 100 milliliters is a volume of our base. We don't know the molarity, but do we know how many hydroxide ions there is in NaOH? Because that's Nb. NaOH only has one hydroxide ion, so we're going to write Nb is equal to 1. So again, in this problem, we're trying to solve for Mb. It's asking what's the molarity of NaOH. So we have to isolate it from the equation. To isolate it, we have to get rid of Nb and also Vb. Divide it on the right side. If we do it on the right side, we have to also do it on the left side because this is a equality. Okay, on the right side, NB and NB cancel out, VB and VB cancel out. All we're left with is MB is equal to NA times MA times VA divided by NB times VB, right? So all we have to do is just plug everything in. I've already identified it for you in the word problem. We just plug it in now. So go ahead and do that. After you have plugged in the numbers, you should cancel out any units that appear twice on the top and the bottom. So we can cancel out milliliters. Now that milliliters is gone, we're only left with molar, a unit of concentration. And that makes sense because we are trying to get a unit of concentration. Now you just type this in a calculator. 2 times 5 times 20 on the top, and then on the bottom we have 100, so divided by 100. And if you type all of this in a calculator, we should end up with, I believe, 2 molars. Right? And that's our answer for this one. The concentration of our hydroxide solution must be 2 molars. In the second example, we have a titration of hydrobromic acid with magnesium hydroxide. 42 milliliters of 1 molar magnesium hydroxide was required to neutralize 10 milliliters of the acid. What is the molarity rather of the hydrobromic acid solution? So titration problem, it involves acid and base, and we're trying to solve for the concentration of our acid this time. It's an acid. So write down the titration equation. In this problem, we're trying to solve for the molarity of hydrobromic acid. In other words, the concentration of our acid. We're going to try to identify everything else other than the molarity of our acid. Okay, so in the very beginning again, in the titration of hydrobromic acid with magnesium hydroxide, 42 milliliters of 1 molar magnesium hydroxide, which is a base. So we have the volume of our base, we have the molarity of our base, we also have magnesium hydroxide, which has 2 hydroxide ions per molecule, so Nb is equal to 2. That was required to neutralize 10 milliliters of the acid. So we have the volume of the acid. Do we know how many hydrogen ions that hydrobromic acid can give? Well, hydrobromic acid only has one H, so it can only give one hydrogen ion. Na is equal to 1. So we have everything. We just need to solve for our molarity of our acid. So we need to solve for that part of the equation. To isolate it, divide both sides of the equation by Na. The only side that will have anything cancel out is on the left side. Na cancels out with Na, Va cancels out with Va. What we're left with is Ma is equal to Nb times Mb times Vb divided by Na times Va. Okay, so we've already identified everything. Just go ahead and start plugging them in. After you plug them in, just make sure you cancel out any units that are supposed to cancel out. So we have milliliters and milliliters here that will cancel out. We're left with molarity, which makes sense because we're trying to solve for concentration of acid. Okay, so just type this in the calculator. We have on top 2 times 1 times 42, and on the bottom we have 1 times 10. So divide everything by 10, basically. Type this in the calculator, and what we should get from our calculator is something like 8.4. And this is molarities. Okay, molarity. If you wanted to, you can say this is the molarity of HBr. You don't really need to, but I'm just going to go ahead and throw that in. Okay, so the concentration of our HBr is 8.4 molars. Now, here's one practice for you to try. Go ahead and try this. Pause the video. In about 5 seconds, starting now, I'm going to give you the answer. Okay, so we should get about 0.44 molars of our beryllium hydroxide solution.